Good evening and welcome to the BS and Beer Show. Tonight we are talking sound spaces, how to quiet your home. So very excited. I am Emily Mottram, architect here in Maine. Tonight I am still drinking the lovely agua from the Energy New Brunswick. Shout out to our Canadian friends. But BS and Beer is a grassroots independent movement here to share building science knowledge through our local meetup groups and this, our Zoom show. Shout out to our two new local groups too. The Brew Crew and our guests volunteer our time each week or each month to make this informative discussion for you guys. We encourage you to start your own local group. For more information on how to get started, visit thebsandbeershow.com or to find a group in your local area that may already be started. The video recording for tonight's show will be available through Green Building Advisor and up on our YouTube channel, The BS and Beer Show. And we want to just give a shout out and thanks to our media partners, Green Building Advisor and Fine Home Building Magazine, for helping us make this happen every month. So, Mike, you got some announcements?
Yes, yes, I do. Mike Maines, a designer in Maine. Tonight I am drinking not just a beer, but my version of a light beer, which is a shandy, so sort of a utilitarian beer, and some good citrus soda makes a really nice, tasty summertime beer. So announcements, we have several tonight. First off, the Building Science Symposium series in Boston next week is sold out. I feel very lucky to have gotten a ticket, and I can't wait to be there. There is one more chance to attend in 2025 in October in Chicago, Illinois. So register there for that one while you can. I'll put a link in the chat box. Travis and his team here put a ton of effort into making these two-day conferences very fun and educational and incredibly affordable. So that's the Chicago Building Science Symposium, October 8th and 9th. Also next week, Emily will be in Denver leading Construction Instructions Women in Construction second annual Building Science Training Summit, along with fellow expert and friend of BS and Beer, Nikki Kruger. There will be presentations, roundtables, and networking opportunities focusing on building science, empowerment, and building confidence. A double entendre there. I like it. I'm chronically behind on podcasts that I want to listen to, but I recently binged the entire library of one I highly recommend for builders and for anyone interested in learning how top-notch builders think and what they care about. It's called the Building Consensus Podcast with our own Travis Brungart and fellow contractor Brandon Jones. The unique premise of their show is that they have very different approaches to how they work, but they debate a specific topic respectfully until they reach a common understanding. Available at a link and anywhere you can find podcasts. Speaking of podcasts, Emily released a couple of excellent new episodes of her podcast, Energy and Efficiency with Emily, E3 with Emily, over the summer. We'll put a link to that in the chat. And last, but certainly not least, Atlanta now has a BS and Beer group. The first meeting will be next week with Allison Bales presenting on HVAC design. Registration has reached capacity for that event, but join their Instagram page organized by builder Chris Knight, along with the South-Based Institute and the Greater Atlanta Home Builders Association, to stay on top of upcoming events. Phew, that was a lot. Travis, over to you for introductions.
And Mike, I can't thank you enough for the kindness on the podcast. And definitely go listen to the E3 podcast with Emily and go see her in Denver. So thanks for that shout out. I am Travis Brungart. I am in Kansas City. And so I'm drinking a KC Beer Co. Helles Lager, which I think I'll enjoy very much. So I'll load that into a protective container while I tell you about our wonderful guests. We have Bennett Brooks, the president of Brooks Acoustics Corporation, an acoustical consulting firm addressing sound isolation between interior spaces, mechanical system noise, occupied space sound quality, exterior noise control at the property line for environmental code compliance, permitting, site development, and planning. Now, they also provide state-of-the-art audiovisual design services Brooks is an MIT graduate and licensed professional engineer, among many other accomplishments. And you can look at Brooks Acoustics site, brooksacoustics.com. Michael put that in the chat, as he's wont to do. We also have my good friend, Michael Crane, which you guys know Michael, but Michael's a business development manager for MP Global Products, who provide building materials with a focus on wall assembly applications. Now, Michael leads the building materials and acoustics division, spearheading the launch of practical acoustical solutions. He has a passion for the building industry, as you well know, and a commitment to quality craftsmanship. A BS in business administration. He's held key roles at several companies, including most recently our friends at Rockwell. And that's how I got to know him. But Michael is the organizer of BS and Beer in Austin, Texas. So he gets a tip of the hat for that. And he's been instrumental in helping numerous other groups start. So I'm thrilled to have you both here. I can't wait for you guys to both tell us what you're drinking, and then we can get started with our presentation. How about you go first, Bennett?
Okay, well, thank you very much, Travis, for the kind introduction. Great to be with all you guys, and this is exciting for me. I love talking about this stuff. So we do have about 2 or 3 hours, right? So never mind. All right. If you drink more, it sounds better. I'm drinking Pemaquid Ale. I'm here in the mid-coast of Maine right now, right down the block from Emily, pretty much. And there's the Pemaquid Light. And if you want to get another view of the Pemaquid Light, you can look at the Maine quarter dollar, because it is the symbol on the Maine quarter. So anyway, cheers, everybody. It's a dark ale. It's nice.
Cheers to that. How about you, Michael? What are you drinking tonight?
I am drinking. Okay, so first off, Emily, I got here a week early. I thought your thing was this week and not next week. So sorry.
Stick around.
Just kidding. There's an audio visual conference in town, so I'll try to keep Denver when you get here.
All right.
So I'm drinking a local Denver beer from Prost Brewing Company. It is a Heffy, so it's one of my favorites this time of year, and that's what I'm drinking.
Excellent choice. We're off to a strong start. Is my understanding that, Bennett, you prepared a little presentation to get things rolling. Isn't that correct?
I did. I have about, 10, 15, 20 minutes. It's going to go pretty quick. Just to give a little basics on building science for sound, and then a couple of case studies just to get the warm-ups going, and then happy to hear all of your stories on good things and not so good things that happen with sound in buildings.
Well, the chat's popping already, but let's get your presentation started, and then we'll go to the chat after.
Okay, so I share my screen for that?
Yes.
Yeah, okay, I can do that. Let's see. Sharing is not turned on. Okay.
Oh, let me fix it.
Let's see.
I thought it was.
Well, we can work
okay,
around
now
that.
you can.
Let's try again. Let's see.
I turned the chat on. They yell at me about
there it
that
is.
every week
Wow,
too.
look at that. She did it.
Poor Emily.
She
She gets
good.
blamed for everything technical. It's not your
Oh, wow.
fault.
Okay, so let's
Definitely my fault. I should know better by now.
let's do the whole screen. Why not?
Well, ideally, this would be a good time for everyone to update their software. That's usually what I get when I try to change anything in a presentation.
All right, so let's see if I put on the slideshow. Let's see if that works. Can
Ooh, that
anybody
looks
see
nice.
any of this stuff?
Looks good.
Okay, well, great. Well, thank you very much for having me, BS and Beer, and to our wonderful hosts. It's great to be with you all, Emily, Michael, Travis, and my fellow presenter. So Mike. So we'll get to all that. But the question was, well, how do you quiet your home? And I'm assuming we're all talking pretty much right now about single family residences. Is that true? Single homes, but a lot of this applies to multifamily as well. So, am I on the right direction, Emily? Am I going the right way here?
Yes.
Okay. All right. Let's move on then. Let's see. So we've got issues, and you've already mentioned some of them, Travis. Sound in the home, in residences, sound isolation between occupied spaces, kitchens, bedrooms, family rooms, and more. And and then there's noise inside the home that would be created by something outside or something inside. And then what is the acoustical quality? Meaning, how does it sound perceptually? And that a lot of that depends on the reverberation and the echoes inside. And that goes directly with the volume of the space, how big the room is, and what the surface finish materials are, how much absorption is in there. And yes, your little blanket that you wear over yourself, that'll help. And a little bit of carpeting, that'll help, but it doesn't do everything. So we can get you some better materials. Um, there's some more issues. Do we have issues with noise at the property line? We've had to put somebody's air conditioner inside their garage because the neighbor didn't like it. Believe it or not, this stuff happens. So we get there. And then what is the perceived quality inside the building and all around, outside on the patio? So everywhere you go, there is sound. You may not notice it at first, but after a while you will. And sometimes it's great, and sometimes you'll say, "Oh, I don't like this." So, what do we do if we don't like it, or how do we plan to make it great? That's kind of where we're trying to go with this. Um, well, we start with the highest quality design and construction possible, and a lot of you are in the design business, and a lot of you out there I know are in the construction business, either as GCs or subs possibly. And every piece is important. It all comes together in the building. So we have to kind of pay attention right from the start. That's the best way to solve the problem. Not, well, we've got calls like, we're pouring concrete tomorrow. Can you fix this? And so we've done that. And we've also come back when there is a problem where we didn't think it was going to be, but we've been living here for a couple of months and it sounds really bad. So when you start off, and I hopefully you start your next project thinking about this, you want to start with the highest quality you can, and you also want to manage the owner expectations so that if they're living in the middle of an interstate, like in the little island between the north and south lanes, they're going to expect some traffic sound. So, and by the way, there's difference between sound and noise. And noise legally is unwanted sound. So, of course, none of us make any of the unwanted sound. We don't make any noise, so we're just sound people here. Let's get into some details. Noise from adjacent rooms, above, below, to the side of in other residential areas, coming from all directions, voices, TV, music, teleconferences like this one. I'm sure we're not bothering anybody next door, right? They all love this. So we're good. And then impacts are usually directly above, and that says unit because this was, oops, I took that from an apartment or condo presentation, but it works in houses too. There was one guy in a house, nice house in Florida, sort of a development house, but you're talking in the $3-4 million range, and I couldn't believe it. I mean, it was not built the way you guys build, but it was pretty lightweight, and so he didn't like his kids jumping around on the second floor in their playroom. 10 years old, 12, whatever, jumping on the. I said, okay, we got to float a floor, and I, designed a floating floor for him, and it had some poured gypcrete in there, and nice pads that you could get from Michael Crane, and so and he said, you know what, my structural engineer says that the building can't take the weight. I'm like, are you kidding me? I mean, how much did you pay for this place? But okay, so we designed a lighter weight one. But anyway, that's you got to start from the start with everything, planning this. So here's noise from outside. We're talking about transportation, basically roads, aircraft, trains, mechanical systems. That's kind of a little bugaboo with noise. You don't want to hear the AC kicking on. Plumbing, neighborhood activity, if you're in a neighborhood, and the construction around is usually temporary. So, but anything you can think of, there's going to be a sound source. The neighbors, maybe in a multifamily, neighbors are a little more important. But it could be it could be your kids, could be your elderly aunt rocking out. So you never know. But here's a little picture of where the sound and noise, unwanted sound, can come from. All over, you see you see plumbing fixtures, music, kids playing. Where's the vacuum cleaner? It's in there somewhere. Maybe it's the next one. Okay, so we have two types of isolation. One is transmitted, which would be we'll call sound isolation. It either goes through the wall panels or the floor panel, floor ceiling assembly, and it can be airborne, can be structure borne. It'll hit the walls and go sideways, go down, and it could be impact. That's usually vertical adjacencies. Here's a couple of more pictures. There's the bagpiper. I love these old pictures. Somebody's snoring. Yeah. Okay. And now this is more multifamily, but it does show some of the types of sources you can get. Here's washing machines, music, TV. Here's somebody with a trash chute. So you might have a trash chute in a big house. I don't know. So what we want to do is kind of when the project starts and we're in the design phase, we're in that before the design phase, we're in the vision phase, we're, programming, we're looking at this thing and, well, what do we want this home to look like? We start to evaluate what the issues. One of the things to do is compare it to standard performance criteria. So I'll give you some of those really quick. A lot of it comes from the building code, IBC and state. Although the IBC, always says it excludes single and double family houses and townhouses. But if you're in a multi-unit, a high-end condo, maybe IBC certainly comes in your state code. Then we have ASTM standards. We have quality evaluations, basically objective, and then ordinance codes. That's your property line right there. Can't bother your neighbor. And then the biggest thing you may have is your occupant or owner expectations, and that's perceived, subjective. Do they feel good about it? And you can actually quantify that stuff, but it's important to get the owner on board early and decide, what do they want their home to be like. So that's important. Get started early in the design phase. We can quantify isolation by standardized testing with ASTM. The numbers you probably heard are STC and IIC, sound transmission class, and impact insulation class. So those are ASTM standards. They have them in the lab, and then you can test them in the building as well. And some of the nuts and bolts of that is here's a wall assembly being tested in a lab, which is basically a big concrete bunker, and they leave a hole in the middle, usually 8 by 14, that you can build a wall assembly in there and blast sound on one side and measure it on the other. And the difference is your go through a little math and you get the single number sound transmission class. This one, the code says between units, you have to be 50. That's not too good. You can hear them talking on the other side. But that's the building code, and there is a law that you can't build it any worse than that. So, but that's, we go up from there. That's what it looks like in the test. ASTM E90 is the lab test, and E336 is the installed test. Here's E336. Here's a loudspeaker making some sounds in the upper room, and it goes through down to the lower room, all different kinds of ways. It goes right through the floor and the ceiling, but it also hits the walls. And once you excite the structure, it goes in all directions. And by the way, stick built is probably the worst for this because wood is a wonderful sound transmitter and vibration transmitter. So keep that in mind. Um, when you hear STC numbers, just remember it has limitations. It's a limited frequency range. The single number doesn't tell the whole story. You can kind of compare different construction assemblies, but it can be misleading. Here's a picture showing that. So there's CMU, grouted filled CMU, STC 48, and here's a, a little lightweight gypsum wallboard construction, which has a higher STC rating. But if you look, I don't know if you can see my mouse, you see this dip in the kind of the frequency graph. This is a frequency graph, by the way. It goes from low frequency bass bah, to the middle to the high crickets, and our speech is right around in the middle here. Well, it turns out that gypsum board has a resonance right in the speech range. So you can get, the way they do the math, and I didn't want to spend a lot of time on that, but you take all these frequencies and you put them in the ASTM standard math, and you come up with the single number rating. You see there's a big dip because of the resonance of gypsum board right in the speech range. So you are going to hear people talking on the other side with this lightweight gypsum wall board on studs, steel stud here, compared to the CMUs. So you got to be kind of careful. You want to look into some of the details of your constructions. Then there's the tapping test. I don't know if you ever saw a tapping machine. It runs on a motor. These little hammers drop on the floor and make that tapping sound. And then you measure downstairs and tells you what's going on in terms of the floor ceiling. Here's somebody putting one in a lab. And here's somebody hammering on the floor over. And on the left side, you can see that that has some nice springy material underneath from MP Global, probably. And then this one over, and so the D, the sound going through, is not so big. But on this side, uh-oh, they forgot to put the stuff down on the floor, and it's going everywhere. So something to keep in mind. And that's an AIIC. The A is when you test in the field. The new designation for ASTM is apparent. The old one was F, that meant field, but they changed it, so it's AIIC. And 45 is the minimum. They give you 5 points below the lab or calculation standard, which is 50 for state code, between units. But in a house, you don't care about that unless you want to have some privacy in your home. So then you might want to think about that. The IIC test isn't all that good because it really doesn't, it's all we have right now, but it doesn't really tell you when you're walking across, or you're going to hear, you might hear the high heel clicks, but you won't hear like the weight transfer. And basically, since you're dropping hammers on the floor, anything soft on the floor, hard flooring needs to soak up some energy underneath the flooring. But if you have carpet, it soaks up that hammer right there. So here's a carpet on 4-inch of concrete slab, and you're getting an IIC of 81. Okay, that same 4-inch slab with oak flooring is going to give you 47. So just because it's a hard surface that the hammer is dropping on, and it'll transmit again all over the building. So the floor material is really important, and if you want to put something hard, which people like on their floors, you need to have some kind of a pad or mat underneath. And Mike will tell you all about those. Again, the limitation of the single number, it helps compare different assemblies, but it doesn't tell the whole story. It won't show up, walking is a much slower rate. You can still hear people walking even if it's on carpet, and especially on joist type construction. And it might test very well with the IIC number just because of the way the hammers hit the carpet, but you still hear everything upstairs. So you want to get some weight into your construction. That's important. It'll cost more. The owner doesn't really see it. It's behind the floor, it's behind the walls, but it makes the building a lot nicer in that sense. So, keep that in mind. It will add some cost because, weight comes with cost. And the other thing IIC doesn't do is gym or dance or work fitness. There's solutions for that. The biggest thing if you're moving around is to float the floor, like we were talking about with the kids' playroom. If you are dropping weights, they actually make pads. Look up either Titan or Rogue Fitness. They'll give you pads you can drop your weights on, and it'll stop right there. It doesn't bounce. It just kind of takes up all the weight. So that's a cheaper solution by far. But floating floors are really nice, and you need some weight. Okay, here's if you're in multifamily. These are coming off of the ICC guidance from 2010. They say code minimum 50 STC, 50 IIC, acceptable in quotes 55, and preferred 60. Now, everybody knows that if you design to the code minimum, you've got maybe a 50% chance of meeting the code once it's installed. So keep that in mind. You probably want to design better than that. And again, talk to your owner, find out what their preferences are. And certain rooms they may want to isolate from other rooms. So keep that in mind. Here's another way of looking at it. Quality level from Marshall Long, good guy. This is for multi-family. And a lot of you are probably building, we build everything. We build everything from Section 8 to multi-mega. But, the higher quality deserves higher quality. So what does that mean? Well, we raise the numbers. The STC, and this is the old FSTC, it should be A now, but high quality 65. If we're looking for some privacy, and really, you're paying huge bucks for your condo, or you want to keep your bedroom private, we're probably looking at 70 STC. So something to keep in mind. And same thing for IIC, because that tap can be really annoying. So we even bump it up a little more. I'll show you an example of an extreme case in a little while. So the acoustical issues we've identified so far: noise inside the residence. We've got standard criteria for the isolation, and now we want to get to noise criteria rating. That's for, say, mechanical systems. So if you're getting a lot of noise from your AC, that means your ductwork is too small, the air is going too fast. Blow fastly on your fingers, and it sounds louder than if you just kind of breathe out. So you want bigger ductwork, again, more space, more, it's always the fight between how much space will I take and, can I slow the air down? But this is all defined in ANSI S12.2 and ASHRAE handbook for you mechanical types. NC ratings. NC is not equivalent to DBA, just keep that in mind, which is A-weighted sound levels. Like typical voice, I'm talking a little louder into my computer, probably 65, 70 dBA. And the NC rating is going to be a little number-wise, a little bit less than that. But you have design criteria for mechanical systems. So make sure your mechanical engineer sees these things. Bedrooms, they go, well, 25 to 30. Lower is better. So you want to keep that in mind. And if you, again, everything in a higher end home should be spring mounted. Everything's on springs. All the ductwork is kind of isolated by rubber or mechanical springs. You don't want that stuff shaking. You don't want it, hear that clunk when it kicks on. So those are all things to think about. Stuff behind the walls that the owner doesn't see. Why am I paying for that? Well, if you want to have a pleasant, serene home, that's what we do. It's definitely science for that. So here's some acoustic quality, also speech privacy. This can be quantified. So do you want to have a home office where you want to have conversations that are not heard either inside or both ways? There are numbers that can be applied to that. Confidential is, privacy index way up there, almost 1. And then under 0.6, you're basically hearing everything they're saying. So you want to get your assemblies, floor and ceiling and walls, to give you the kind of performance there if you can have privacy if you want it. So this is part of the due diligence of the project. You sort of do an evaluation. What do I want? What does the owner want? What can we recommend to them so that they'll be happy? And that comes from experience, but you know that you've got this science behind it, building science, and beer is behind it also, in the better designs. And so there's objective criteria that we just went over a few. We didn't talk about reverberation, but if you have a large foyer and it's very echoey, so people won't like that. They'll say, "Oh, bring my guests in. They they can't hear anything because it's so echoey. So we have to put absorptive surface materials. Fortunately, it's not just what I would do as an acoustical engineer. If I needed to put absorption in a room, I just go down to Home Depot and buy all the 6-inch pink insulation I can find and staple it on every surface, the walls, the ceiling. Uh, let's see, what's wrong with that? As an engineer, it's great. As anybody else, it's well, it looks terrible. The fire marshal is not happy. It's very itchy. That's not good. So, and by the way, I did install insulation, so I know what I'm talking about. But so there's fortunately a lot of materials now, hard looking, we call it hard looking materials, plaster, wood, metal, glass, just about anything you can think of that will absorb sound. So it's an amazing array of materials, and Michael will be talking about that a little bit more. And then you have the subjective criteria. What does the owner think? What does the occupant think? So all these things to think about in your design and your implementation, your installation of these designs. So while we're at it, I guess we got a little more time, a few more minutes. We'll go into some case studies that kind of apply some of these principles. The first one is the overview. Identify some potential sound quality issues in a proposed project. Then we've got some construction noise that is on site that we're trying to keep from the neighbors. That's a property line and neighbor happiness kind of thing. Then we have road traffic noise. We can't shut the road down, but we want to enjoy our backyard. And then finally, a home theater, which kind of, pulls all of those things together that we're talking about. So here's a proposed home on an island. Nice looking place. I asked my AV guys to take a look at that, and they said, "You sure that's not a resort?" No, that's somebody's house. It's gonna be. And so it's pretty big, and we say, "Okay, what's going on there?" Over here, we've got the main house, and over here, this is I don't know, they call it a beach club. So we'll see what happens with that. Let's take a look at the architecturals. Okay, first floor, I see a bunch of stuff happening. Hard to read. I don't know if you can read this. Family room goes out to the spa. Here's, let me take a look at it real quick. There. Okay, chef's kitchen, and then this sort of show kitchen. And then we've got the home theater over here, a big staircase, open 2 stories, a guest suite back here, all open, all glass. That place is going to sound terrible if they don't do anything about it. The biggest opportunity for absorption will be the ceiling. And then pick and choose where you can go elsewhere. The theater will be kind of interesting because you want to isolate that when you're listening to Apollo 13 or rocking out in there with hot yoga or something. Um, you want to keep that from the rest of the house because they'll get annoyed with you. Here's the second floor. I don't know if you can read this, but there's a master suite over here and a bunch of bedrooms. Of course, the stairway. I cut off a little bit of it so it would fit on the slide, but it's a big place and it's all open and it's all hard. So sound from one side is going to really travel over to the other side, especially down this big curvy tube of a house. So a lot of things to keep in mind while doing that design and the build out. Okay. How about keeping construction noise on site? So here's a site that's sandwiched between a couple of neighbors. And they want to keep they want to meet the local code and they want to keep the neighbors happy. They want to be friends with them. So we came up with a system where we would put a big sound wall around it during construction. This will be 20 feet high. We looked at 25, but that didn't buy us much more. So it's really two stage. Here's a cement mixer, and we built kind of like a little hut around it, which we can move around, pick up and move around as the cement mixer moves around. And then, all the other tools that they have, backhoes, etc., site work. And then the 20-foot wall catches the rest of it. So this is a rendering from a drone photo that shows what the piles of material will look like and what the wall will look like. Here's one on the north side, one on the west, and you can't really see the one on the south, but all the calculations show that that'll blend in and pretty much be mostly below the background sound from local traffic and the ocean waves and so on. So that's keeping the site construction sound on site. Here's another one. This is somebody who had a busy road in the backyard behind these trees. So we went out, did a bunch of measurements. This is their pool, kind of an alcove area, dining, and so on. That's the short term. That's the sound analyzer on a tripod, you can see. And then we strapped one up here to measure for about a week, just to see what it varies over day and night. And then came up with a wall design, which looks like this. So you have the traffic going by, trucks and autos and motorcycles and heavy trucks, light trucks. So the city, we're looking at it and we're trying for, let's say, about a 15-foot wall, see if they'll approve that. We would not drop down below 12 for sure. Most towns or cities like about a 6-foot or 8-foot max, but you really need the extra height, especially with the 2-story house. It bounces off the house. But the city wanted to know, why do you need these returns? What do you need to put these side pieces? Well, we drew them a picture because, when the truck's approaching from the south, it's scooting right back in here, the sound of the little yellow arrows. And so same thing for the north. So hopefully we're going to get those side pieces approved. So that's how to make the backyard more pleasant with a heavy traffic and make it happy. Okay. Now, okay, so let's tie it all together. We've got home theater design, and this is I've got a little video to play for you. We've got basically extreme sound isolation, mostly from inside the room to outside the room. I don't think we're as worried about outside the room to inside. The mechanical system, noise control, you don't want it to be, blasting when you're in the quiet part of the movie. And then the acoustics inside the space so that the bass and the high frequencies are balanced. And the diffusion is like the difference between a frosted white light bulb and a bulb with clear glass. The clear is going to be have more glary looking, but the the frosted one will diffuse the light. And in the same way, we want to diffuse the sound so there aren't any hot spots or dead spots in the room. So I've got a little presentation that this one would work in a single family house. This is kind of extreme because this was in a condo. Actually, it was a very super high-end development, and the developer took a unit and he wanted a home theater inside his unit that wouldn't bother his neighbors. So we kind of had to really go what they called the bomb shelter. But so here it is. And this little video, you may have to adjust your sound. The music may be a little loud. We put this together to show the construction kind of from the ground up, with it showing all the layers of walls that are separated by air spaces and insulation, ceiling that's floated on springs. The floor is floated also on pads, very heavy, thick pads, and then all the stuff that's on the inside to smooth out the sound. So enjoy the sound. The music might be a little loud. We put this together for the owner so that they could get the general idea. And we tried to keep it down within a minute or so to be within his attention span. Just kidding, just kidding. Good owner, great developer. Okay, so let's go. Any developers in the house?
There isn't any sound on my end. So I
Sound?
don't know
Just
if
your
it,
voice.
yeah,
okay.
just you talking, but the visual is
Sure.
entertaining.
Good. Well, you see all the layers of the walls, lots of gypsum board, specialized gypsum board, which Mike might be able to tell you about. This thing was set up actually for Dolby Atmos, which is like a 13 speaker system, which some of the new movies are being mixed in. So it's a lot of speakers. There's a standard for that, Dolby Atmos, and we wanted to build to that. In the back, you see a diffuser, a big panel diffuser. There's some on the walls. Here we're talking about the looking at the ceiling. It's got a raked floor so that the seats, are in rows that go a little higher. There's the ceiling on springs so that we don't bother the people upstairs and then get the flanking sound sideways in the concrete slab. We got to basically build a box in a box. There's the screen. You see some of the speakers on the sides and the way the seats, between all the absorption, all that yellow insulation that you saw up in the ceiling and in the corners, smooths out the sound. And the diffusers help smooth it out. And the box in a box keeps the sound inside. So they can play it and watch as much as they want late at night. And there we go. I don't know if you got the music, maybe it was coming through my mic. But there we go. So let's see what's next. All right. So we want to solve these issues. As we said earlier, start with the highest quality you can in design and construction. It will add somewhat to the budget, depends on what you do, but you can figure, you get a lot of acoustics for, I don't know, $100,000. If you're building a couple $1 million home, it might be worth it. So, you want to manage the owner expectations. Take a look at the pricing, look at the estimates. See where you can, you want to do some sound rated doors maybe in a bedroom area or an office area. They will cost you a little bit. They come in all kinds of materials. But you want to, first of all, as a as a professional, as a designer, and or a builder, you want to minimize your risk exposure to having any issues that you have to do callbacks or, God forbid, any renovations after the fact. So manage the owner expectations and be aware that you want to reduce the risk exposure for yourself and you want to maximize your return on investment. So I think that's it. What else do we have? Thank you very much for having me come by. This is a pleasure.
Nicely
Awesome.
done.
There's definitely lots of questions. And since you referenced Michael's products like 16 times in your presentation, I think, Michael, everybody in the audience wants to know how to do it and with what.
Well, like Mr. Brooks said, there's a lot of different ways. And to really get to, it's much like thermal design, my kind of passion in the insulation. There's a lot of different ways to get to the same result. It's understanding how things work together that makes the most sense for an assembly design. You have choices that start from the framing stage, especially when we just talk just basic wall assemblies. We can do a single stud assembly, just a standard 2x4 or 2x6 that's in every house in the USA. Or we can expand it to a 2x6 plate. We can do staggered stud framing. We can even do double stud framing. So there's decisions that you can make just on just the way we frame a wall assembly, and then you put it together. I saw a couple comments on here, just double layering your drywall, and so I think it's really important to understand what these products do. I love the fact that Mr. Brooks brought up that idea where drywall dips down into that speech factor and how it can do. Now, that's also saw where somebody was talking about the difference between 1/2 inch and 5/8. I prefer 5/8, even though on paper it doesn't look like much. But when we look at these STC tests, we've got to understand this is an average of transmission loss across 16 different frequencies. And so where one may excel and have a better STC, it may depend. We may be dealing with a frequency that is on a low end, where the one that doesn't test as well on the STC does better. And so it's putting all this information together that makes a good wall assembly, in my opinion. So is there good standards to developing a wall assembly? Yes, there is. And so, but I usually dissect the layers of sound control into different sectors, and of course mass being one of them. Adding more mass, that's adding another layer of drywall. Dampeners, like my product's more in the dampener space. We are reducing that vibrational energy coming through, trying to prevent it from going through to your framing assembly, especially when we deal with wood studs. And then you have isolation, decoupling your assemblies, like a double stud framing method or a resilient channel. You're trying to isolate those sounds and keep them in a space. And then you have, absorption, which is like your insulations, your sound panels, fabrics on the wall. Acoustical sealants can be considered an absorption method. One that I used to install myself, I enjoyed dealing with acoustical sealants. And in fact, I had a job that went south because they value engineered my acoustical sealants out of the bid. And so that's what you get with VEing. Very little value and no in engineering. So
that was actually one of the questions in the chat, so you're talking about it. And thank you to Jeff and Kurt, who have been diligently answering questions in the chat as well, which was for the recording for people who aren't going to get the chat. Is acoustic caulk really better than regular caulk?
So acoustic caulk is like they have to pass a rating test to be considered an acoustical sealant. So that's really the difference. I loved what forget which one of you mentioned it, but the difference is a regular caulk is going to harden, it's going to form more of a bond, and then acoustic caulk is going to keep flexible. So as things expand, contract, it still moves with the building materials.
That's right, Mike. It has to say flexible. There is an ASTM standard on that too, C919.
Yep.
And the funny thing, you mentioned VE. A friend of mine tells me it really stands for value extraction. We pull all the value right out.
100%.
And so when people want to know about caulk, I say, okay, I talk to the drywall guys and I say, all right, just think of all the caulk that you're ever going to use for the rest of your life and triple it for this project. Because you got to fill all those little holes. That's where the sound goes
Right.
through.
Spooky.
Absolutely.
So yeah.
The first audience question is actually from my friend Bob Morrison, who inspired this show along with the conversation with Michael. He's renovating a duplex into a high performance duplex. I'm sorry. And the dividing wall is a concern for him. He wants it basically as soundproof as reasonably possible, but he doesn't want to go overboard. So just I'll list off his questions. How reliable are the vendors' estimates of their assemblies, STC ratings? How can the STC of an unknown assembly be estimated? For example, estimating the effect of added mass loaded vinyl to an insulated staggered stud wall, and what assemblies are good, better, and best for the STC of multifamily apartment separation walls.
Yeah.
You take that one, Mike.
Well, I'm going to speak to the vendor side since I am a vendor. So I think what we really, it really comes down to how they got that STC rating. Is it done in-house or did they get it third-party tested? Third-party testing usually don't lie. It's done in a laboratory setting. Now, it is different than the field testing, which could have some different situations that isn't really recorded in a lab setting. But I would say that if it's third-party testing, then it's reliable information.
Yeah, that's a great point. I always ask for the lab test if I can get one. They don't always have them because, it does cost money to send things to the lab. Not as much as you'd think. Floors are expensive, but walls aren't that expensive to get tested. So it's worth it.
About $5,000 a pop.
Yep. And so it's not that bad. To answer the mass question, I would say yes. If you're using the loaded vinyl or another piece of drywall, and by the way, the specialty drywalls that everybody has now that have the rubber inside, like Quiet Rock or Silent FX, I think is the USG version. And basically what they do is they get rid of that little dip for the speech inside. It's the rubber soaks up that energy in there. So that helps. But if you double the layers, you're going to pick up somewhere, I would say 3 to 5 STC points. If you're on a staggered stud or a double stud where the walls aren't touching each other, you'll go more towards the higher end of that. So if you let's say you have one layer on each side, then you do 2 layers on one side and 1 layer on the other side, you might pick up 3. And if you do 2 layers on both sides, you might pick up 5 or even close to 6. You want to see if you can get some insulation in there, either blow it in or, however you need to. Open cell foam, or, if you can blow in some cellulose or something, that helps too.
Yeah, I'm not a big fan of the spray foam inside the cavities. I know a lot of contractors that have had to resort to using spray foam because they've been having issues getting bats. But But yes, like our product, we've done testing on staggered stud assemblies, and it's it's that isolation between the studs. Yes, your plates are still connected, but the decoupling of those studs from the side to side help a lot in increasing that assembly. And whatever, if you can do more on the outside, on both sides, then the better it's going to turn out. And so,
Absolutely, absolutely. My favorite, I don't know, can I say brand name here as far as installation? Any of the fire
Sure.
safe bats are probably good. I like mineral wool because has a little more absorption than fiberglass, a little more expensive. It comes in bats, and 4 pound per cubic foot has the best absorption. So that'll help you the most. The fire bats are usually about 2.5 uh, pounds, but like a rockboard 40 or similar will give you probably the best. You don't have to go heavier. And, if you go a little lighter, fire safe is okay about 2, but your, half a pound insulation won't soak up as much sound as your heavier insulation.
yeah, I think safing's around that 4 pound a cubic foot mark,
Yeah.
if I remember correctly.
Yeah. So I hope that answers the question.
Yeah, I hope so.
Do we have time for another one?
We have a bunch queued up here. Let's see what's a good one. When do you guys want to ask one?
Yeah,
I got
I
one.
was reading through, like, there's lots of interesting ones. Travis, do you have one?
Yeah, I feel like a lot of our audience would really like to know which is better, green glue or mass loaded vinyl. I think Allison Bales asked that in the chat. That's a yes, one or the other. That's a quick one. And then we also have would like to have recommendations for working in existing homes and spaces. Would you lean towards adding materials or changing materials out, like wall panels and insulation? So first, each of you answer green glue or mass loaded vinyl.
They're different. They do different things.
Yes, exactly.
Well, then explain,
Okay,
please, Michael.
so mass loaded vinyl is exactly that. It's a mass. It's a barrier. So it's going to be block. It's going to be more rigid. Where green glue is a dampener, and so it's a viscoelastic compound that kind of forms a bond between two sheets of drywall.
Okay,
Sometimes
so if I was trying to solve a problem in a space, and let's just assume that I'm operating in reality, so budget is an issue. I have installed both of these products, and my recollection was that the green glue was significantly less expensive. Am I still correct about that?
Yes.
Okay, so that might be the more entry level solution for a step in the right direction. Is that fair?
Yeah.
Okay.
Well, that's true. I mean, we've had situations where, we need to build out the demising wall between two high-end units, but the bathroom's already been, all that's been poured. So you can't move the toilet out to put another stud row in because the drain's there and they're not going to move that. So we, use the mass loaded vinyl, even though it's more per square foot than gypsum board, just so we can save that extra ½ inch.
So I'll tell you, and Travis, when he introed me, he said, so what I like most about our product is the practicality of it, the ease of install. And so that's what I look at when I look at building materials. Sure, sometimes we have to deal with hard to deal with materials, but if we can get the same result out of a product that is not hard to deal with, it speeds up the process, and that's the one I want to go with, personally from a contractor point of view.
Absolutely, Mike. I mean, I got a story for you there with schools. You have to meet a certain STC between classrooms, and it turns out it was 2 layers of sheetrock was the standard assembly. Turns out we ended up going with the quiet rock, which was 8 times as much, to buy, but the labor was, in 1 layer was a lot cheaper than 2 layers. So they went basically these, state money, they decided to go with the quiet rock instead of 2 layers of standard type X.
So I think to continue Travis's question there from the first part was, what do you do if you inherit one of these terrible things, right? Do you start taking apart the materials or do you add more materials to it? Obviously, in a condo situation, you might not have a lot of,
I actually have testing in queue just for this situation because I love retros so much, and where we just take our product and we put it over existing drywall, put a layer on top, and see what it does to the performance. If it helps, if it doesn't, I don't know. I just want to know. I'm curious to know what the result's going to be, and so that's scheduled for later this month. So
I think you can get some good results if, let's say, you put a 1 pound or a 2 pound mic loaded vinyl on a wall and then cover it with some sheetrock, and
good.
you're adding a lot of weight. You're gonna run up, the problem you're gonna run into is how much flanking are you getting? In other words, you're blocking the sound that's going through that wall panel, but some of it's hitting the ceiling and then going sideways. So there's, it's not as much maybe as going through the panel. So
Well, we
you can
can do
only put so
things
much
to
weight on until you hit that.
offset that in the way that we install at the lab. We can put some acoustical caulk right there. We can cut everything 1/8 of an inch shy, so it has that flexibility there.
Exactly. We always spec out 1/8 to 1/4 gap between the walls and the wall ceiling, wall floor, and then fill that gap with acoustical, basically non-hardening caulk. And if you have to try to build more of a box in a box, you can drop the ceiling on some soft mounts, which come in either neoprene rubber or neoprene and steel springs. So you if and sometimes in some of these situations, it's worth it. And in a retrofit, you have to look at the economics and see if it's going to be worth it.
I was going to
I,
say, oh, sorry, Travis, do you have a question?
no, please continue. I've got something after.
Oh, I was gonna say, in addition, one of the other questions asked, and you guys get to play with all the fun stuff and do this and figure this stuff out, but a question was whether or not there's any software that simulates your design effectiveness, if you established your goals.
Yes.
There is. Go ahead, Mike. What do you guys use?
So we use a software out of New Zealand called Insol.
Yeah.
Yeah.
Insol's great. They've got the best algorithms. Uh, we actually built ours from math loaded up, but now Insol has it all, and it's so much easier, and it makes
Yes.
nice graphics. It doesn't do everything,
No.
but it does a lot. And there's probably some freebies out there that you can get. Plus, there's all sorts of stuff you can get online going even way back into the 1960s and 70s. It's called the California Book. And when you get into some of these older houses and you see the plaster on lath and stuff like that, you need the California Book to tell you what those STCs are going to do. Because they don't think they have plaster on lath and Insol. I got to check on that one. But
No, they have some limited assembly options in Insol, but it's a great start and it gets you an idea on how something's going to perform. It's how I do my comparative analysis. And even though we've got our stuff in it now, it's still limited just because we've got it based off a few tests we've got. So the more testing that we do, the more we dial down and get more accurate numbers out of the software. And so likewise with the product set I'm comparing against, like a lot of these that we're talking about, the mass loaded vinyl, the quiet rock. And so, and what I found so far out of my thing is it really depends on the assembly design. I'm going to go back to that. It depends on the assembly design on how those products perform. And so I've seen some that they do better than ours, and I've seen some where ours does better than theirs. And so it really depends.
Yeah, like you said, Mike, I agree. Testing is the king or queen, if you will,
Yeah.
of the results. But that's all done in the lab, and you never know how that assembly is going to fit into the rest of the building structure. That's the mystery part.
Yeah. Agreed 100%.
So I was going to add, because there was some talk about acoustical sealants, and we've had Basic on, Steve Basic, popular guy in the building science arena. He did a bunch of the details on Green Building Advisor and Building Science Corp, excuse me. Anyway, he routinely favors this Trimco acoustical sealant, which I know Michael has messed with in the past, and I have used, but I hate it because of the extremely difficult cleanup, the sort of the stringy. It's very unpleasant to have on site, and it's unpleasant as a contractor to install anything that never cures because you can't clean it off of anything. Like Jake Bruton tells this great story about watching his guys cleaning their arms off and their tools with diesel at the end of the day, and the carcinogens that go home with those guys is a concern. So I don't favor that product, and I do a bunch of stuff with our friends at Sashco. So I phoned a friend. I texted Nathan. Nathan Ferraro is a chemical engineer who happens to be a marketing guy at Sashco, and I said, "Hey, I'm just curious because Allison Bales asked, are there other caulks? What is it? I think Allison said, might some caulks not tested for acoustics be just as good because they don't dry out and harden? And which ones are they?" Now, obviously, Nathan, he's a Sashco guy. He's going to tell me that the Big Stretch is a great product for this, and it's highly elastic and all that stuff. So this is not a Sashco commercial. We have two sound attenuation experts here. What say you, gentlemen? Nathan says that caulks that become hard and brittle would do a better job of transmitting sound, but something that remains supple and elastomeric would be sound deadening. Is that what your experience is?
Correct. And I've had firsthand experience using the Big Stretch on a sound wall, and I like it a lot. We covered our outlet around our outlets with it, all the way around the perimeter. It really flows out good. It stays really moist and expands and contracts, and so I enjoyed using the Big Stretch. And it may not be rated as an acoustical caulk, but I think they've tested it to that standard.
That's what Nathan said. So that's consistent. I never doubted Nathan, but it's better to have an expert say it than me.
As long as it stays flexible. That's the thing.
Yeah.
And there's an ASTM committee, C24 committee. I'm on that just because I'm interested in caulk. That's a little nerdy thing, but I don't know what those guys know, but there are some standards on it. And your typical brands are Sheetrock brand, USG, GE makes one, Quiet Products make one. You guys probably make one, Mike. No, you don't make one. So as long as it stays flexible for two reasons. One, it soaks up the vibrations if it's rubbery.
Mhm.
And the other reason is it won't crack, and that, believe it or not, the sound gets through the cracks.
Wow.
Yeah. So I was going to add a third one is the air sealing.
Exactly. Well, if you're going to get the full rating out of a wall, the room basically has to be airtight.
Right.
So your air changes aren't coming through the cracks in the walls and all the sound. Your air changes are coming through the air system.
Right.
Which is also designed to be quiet. But one thing I will give a little trade. I mean, people talk about the one guy. We spec'd out a job, and we said you can use the green glue in between the layers of drywall, or you can use caulking. And he wanted to know, do I have to have both? And I said, no, you don't. If you want to save on the green glue, because they had a pallet of it, I said you can take your caulk gun and you can do like S patterns in between, on top of the lower layer, and then put your outer layer or next layer on. And the other thing is always stagger the studs because or the joints, because you don't want the joints one on top of each other. So that'll help block more sound. So if you have two layers, you put one up and then you put the next one up either staggered or horizontal and vertical. So your joints don't line up. Because you're supposed to caulk all the joints before you put the mud on and tape it. Because the mud will crack and let the sound through. So a lot of tricks. Caulking isn't as easy as you think. And the other thing is, get the 5-gallon bucket with the air gun, because if you try squeezing the applicator, you'll end up looking like Popeye at the end of the job.
The Milwaukee M12 handheld is the way to go for cordless tool aficionados. That's a very, very efficient applicator.
Excellent.
So unfortunately, I'm the bearer of bad news. We went 10 minutes over, and I know there are people in the chat who still have burning questions. So we will try to post the questions on Green Building Advisor and encourage both Michael and Bennett to continue the conversation there. So if you've got questions that didn't get answered, and maybe we just need them to come back and do a whole nother show on like, what do you do inside your media room to make the sound? And everybody wanted to know what you put on the ceiling of that Snake Lake building to make that thing sound better. So, but
Whatever you want to
unfortunately,
look good. There is acoustical plaster. It's
oh,
very
look at
smooth.
that. Acoustical plaster. So I appreciate both of you taking the time to come here, share your knowledge and expertise. I now think I have more questions than I had before we started, and it was absolutely awesome. So thank you for sharing your time. Great to see everybody in the audience. Thank you for joining us, and we'll try to follow up with some of your questions on Green Building Advisor.
Thanks, everyone.
Thanks all. Appreciate it, guys. Have a good night.
Pleasure.